problems together. This autofocus is actually driving me crazy. I need to buy something. Okay, so let us start with some problems. I have already designed some of them here. So, example, let me start with what we had before. I don't know how many of you have solved that. So let me make it simple. I think we will have problems here today. Can you bring your hand in front of the camera, please? And just take it away. Let's see how it works. I don't know why this is doing this. Yes, it's not working today. I don't know why. We can ignore the other board probably. That this is not disturbing you at least. Every day it's getting worse actually. Maybe it's because of the light or something. May you please turn off the light? No, it's not because of the light. Just turn on the lights. No, turn off that light. This light, turn it. Yeah, keep it. Okay, no, yeah, and then turn off the lower one. Yes, yeah, it seems better. Okay, but I have to remember that I have to write only on this board. Okay, so let us see how this will go this time. Okay, so we want to start with this example. If you remember, we were talking about. So I would write determine. Local extreme points and classify them. So of course you know that the simple ones is the polynomials one. I don't think you have any problems with that. You can immediately solve those kind of problems. And of course this is main focus of the exam problems, yes. But let me just do some of these exponential functions. I wrote something on the board, but we didn't have time to solve it. I don't know how many of you have actually solved that one. What we have to do, we want to find the local extreme points of this function. So the first step, you know, is to take the derivative of this function. So it becomes e to the power of x minus 1. And then we have to equate this derivative to 0. And then it means that e to power x minus 1 is equal to 0. But that's a very simple one, yes? So you need to solve this equation. This is an exponential equation. Here, it means that x is equal to ln of 1. But of course, ln of 1 is just 0. So x is equal to 0, yes? So this is your candidate for a local extreme point or maybe a terrace point. And then you go to the table. And then you have x and you have 0. You have f prime here. You have f. The derivative at this point is 0 because I myself equated to 0 and I got that. and then I have to put this number here. So what is that number? If I put 0 in my function, because this is the function row, so I put 0 here, it becomes e to power 0, which is 1 minus 0, so this becomes equal to 1. Yes? Understandable? Okay, and then what happens? I need to determine the sign of the derivative before that and after that. Okay, I told you that of course, you know why, because this function is a continuous function and its derivative is continuous. So I just pick a random point before 0 and check it into the derivative. For example, let me choose minus 1. Okay, what is your guess? If I put minus 1 in this function, of course, you might have calculator available, but assume that you don't have it. If you have your calculator, you choose a random point, for example, minus 1, and you put minus 1 in the derivative, e to power minus 1 minus 1. You use the calculator to calculate it, okay? And then see if it is positive or negative. But it is not needed actually here, because hopefully you know, like pi number, that you know that is 3.14 something, all of you have in your memory. It's good to have something about the Euler number as well in your memory. Do you remember what was the approximate value for this? Up to 2 decimal points?
2.72.
Yeah, 2.72. Okay. And then it means that if I want to calculate e to the power of minus 1 minus 1, what is your guess? Is this number without calculator positive or negative?
Negative.
Why?
Because of 1 divided by 2.72.
Yeah, exactly. So the e to the power of minus 1, you interpret it as 1 over e minus 1. Yes? And then 1 divided by a number which is a little bit bigger than 2, it becomes definitely smaller than 1. And I'm subtracting 1 from it, so it becomes definitely negative. So this part is negative. And what happens for after 0? I just put a random number after 0 again. Which one is better? 1 probably. Yes, I put 1 here. Then I will face this number, e to the power of 1 minus 1, which definitely is positive this time. Yes, because e is around 2.72. So this becomes positive. And then here I have decreasing, increasing. So this point is the only extreme point. And what is the type of the point? The type of the point is a minimum. Yes? So I would say that 0 and 1 is a local minimum point. So you see, even though I don't know why these examples are absent in the book, but this is not far beyond your math knowledge. You should be able to solve it. But now let me increase the level of that a little bit, okay? So number 2, f of x is equal to 3 over 2. I hope that I designed it correctly, because if I make a little bit of mistake, then it is not easy to solve it as well. So minus 4e to power x plus 1. Okay, so what should we do for this function? Just tell me, what should I do? Just interact with me. What is the first step? I take the derivative. Okay, yeah, can you tell me what the derivative is? Carl, you want? Can you?
3 over 2 times 2e to the power of 2x.
Yeah, exactly. So 3 over 2 times 2e to the power of 2x. Yes, because this 3 over 2 is a constant, this 2 goes down, and I have to repeat the function. That's an exponential function, we know. Okay, can you continue?
Minus 4e to the power of x.
And?
Plus 1.
Plus. Of course, can I simplify it a little bit? Yes, because this 2 here will cancel that 2, so let me just write it in the most simplified form. So this becomes this. Okay, so the first step is completely easy, actually. The second step is equate the derivative to 0. Yes? And now we want to solve it. So I equate the derivative to 0, and I want to solve it. So 3e to the power of 2x minus 4e to power x plus 1 equals to 0. I just want to wait a little bit for you because it is not that easy. Just wait, okay? Let us, everyone thinks, then I will come back to you. We want to solve this equation, okay? This equation was easy. This is not hard. It's a little bit technical. You need to remember something from some ideas. Just let me wait. I want you to try to solve this equation, or at least to come up with an idea how to solve this equation. And of course, if you know what to do, you just continue. You don't need to wait for me. Okay, now can you tell me, do you have any idea how to solve the problem, even if you haven't got the answer yet, but what is the idea to go for the solution? No ideas? Yes, Dylan?
You take the auxiliary value.
Yeah, auxiliary variable is the best choice. Yes, here, because if I take e to the power of x equal to a new variable, so I would say to solve this, so I face a problem, not because of my derivative knowledge or whatever. This is not the new lesson, but we can solve this using the auxiliary variable method. Yes, I would say let e to power x, let us give it a name. Let e to power x be called t. Yes, then what happens? E to power 2x, what would be the name of e to power 2x?
T squared.
It's t squared. Everybody agrees? Yes, so it becomes t squared. Therefore, instead of e to power 2x, I can replace, I can substitute t squared, so it becomes 3t squared. And then instead of e to power x, I can substitute t. And then I have plus 1 equals to 0. But this is not a problem, a big problem for you. Yes, it's just a simple quadratic equation. And I prefer to use ABC formula because if I want to use PQ formula, I have to divide by 3 first, and I have to deal with fractions. Yes? Any questions so far? Okay, and then I solve this simple equation. I find t, and I hope that I can solve this simpler equation, and which we can. Yes, because if I have a number, this is part of the lesson this year, that how to solve this using the ln function. Yes. So let us go and solve this problem. So let me write the formula. So the formula t is minus b, if you have forgotten, square root of b squared minus 4ac divided by 2a. Yes. And then this becomes minus b. This coefficient is a, this coefficient is b, and this coefficient is c, of course. And then it becomes minus b, which is 4 plus or minus square root of b squared becomes positive 16 minus 4 times a minus 4 times 3 times 1. And then divided by 2 times a, which becomes 6. And then we continue to calculate this, so it becomes 4 plus or minus 16 minus 12 is 4, so it becomes 2 divided by 6. I will get 2 answers, yes? One answer, t is equal to 4 plus 2 divided by 6, so this becomes 1. So one answer is t equal to 1. And then the other answer is 4 minus 2 divided by 6. So it becomes 2 over 6, and it becomes 1/3. Yes? So it means that the other answer is 1/3. But these are just intermediate variables that I brought in to solve my problem. I have to use these t's to be able to find x. But this is a very simple task now, yes? So I would say if t is equal to 1, what happens? Instead of t here, I put 1, and then I get e to power x is equal to 1. Of course, you can immediately even guess what is the answer here. It's ln of 1, but ln of 1 is famous, so it is equal to 0. ln of 1 is 0, yes? And then what happens? The other scenario is that t is equal 1/3. So I put a 1 over 3 there, so this gives me e to power x is equal to 1 over 3. So what is x now? What is x? What is x here, yes?
ln of 1 over 3.
ln of 1 over 3, I myself prefer to write it a different way. If I immediately write x is equal to negative ln of 3, do you agree? Or we can keep it like that. It doesn't matter, by the way. Yeah, let us write that. Do you agree that these are the same? ln of 1 over 3 and ln of 1 and minus ln of 3 are the same. Why? Because ln of 1 over 3 can be written as ln of 1 minus ln of 3. But ln of 1 is 0, so it becomes minus ln of 3. Yes? Understandable? There are 2 ways you can solve this. Let me just write it here. So ln of 1 over 3, do you remember if I have a fraction, ln of a fraction is the ln of the numerator minus the ln of the denominator, yes? ln of the numerator is ln of 1, which is 0, so what is left for me is minus ln of 3. This is one way of looking at it, yes? The other way is to take it off, yes? Instead of 1 over 3, you can imagine this is another name, yes? 3 to the power of minus 1. And I told you that if you have an exponent here, this can go to the back of the logarithm and be multiplied with it. So this becomes minus 1 times ln of 3, but nobody writes like that. People write this, yes? So these are 2 different ways of looking at the same problem. Anyway, we have 2 solutions. One is 0, and the other one is ln of minus ln of 3. Is that understandable? So exactly, you see, even though this is not an example in the book, I don't consider it a very hard problem. Well, of course, I consider it an A-level problem, but it's not hard to solve this if you have enough experience from what you have done before. Okay, so these are my numbers. These are my candidates for local extreme points, yes? But I have to go to the table. So what information I need, because I don't have that board, so which one we need? We need the function, we need the derivative. So if you don't mind, let me just clean this. We don't need this one anymore because we just needed these answers. So we need the derivative, we need the function. Yes, okay, can I erase that? Okay, so now we go to the table. We need to set up a sign table here. X, f prime, and f. Let us avoid calculator as much as possible, but of course you can check that. First of all, I need to arrange these numbers. So which one is bigger than the other one? Zero or minus ln of 3? Yes?
0.
Yes, but let me no 0 or minus ln of 2. If I have this, or so minus. So is this a negative number or a positive number? For example, if I ask you what is ln of 1 over 3, is it a positive number or a negative number? So you need to be a little bit careful. Yes. So ln of 1 over 3, you can use your calculator, but predict what is this number? Is it positive or negative? So let me just write ln of 2, ln of 3, ln of 1 over 3. I want to compare them with respect to 0 and 1. Okay? So is this number, so let me write it here. This is the x-axis, here is 0, here is 1. If you want to put ln of 2 somewhere, here, 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 where do you put it? Without calculator. And where do you put ln of 3? And where do you put ln of, say, let me clean this, ln of 0.5? Okay, so let me forget about these things. This is the x-axis. Here is 0, here is 1. And I don't want to be precise at all, but I want you to understand where should I put ln of 2? In this part, or in that part? The same for these two numbers, without calculator. Yes, please?
ln of 2 is under 0. So.
Under 0. So you say that I put ln of 2 here. Okay, and then?
ln of 3 is over 1.
ln of 3 is over 1, yes.
And the last one, I'm not sure.
Okay. Any other opinions? Yes, Stephen?
And ln of 1/2 is negative
ln of half is negative, yes.
because it's 2 to the power of -1, and then you put the minus sign on the left.
Okay, so let me ask you, how do you understand an ln is bigger than 1 or smaller than 1? Let us solve this problem first. How, by looking at an ln, you realize that that ln is bigger than 1 or smaller than 1? Yes?
If the ln is larger than e, it should be bigger than 1.
You mean the number in front?
The number.
Yeah, yes, exactly. Because you know that ln of e, I've lost that word, yes. So ln of e is what? Is exactly 1. Okay? And then, of course, then you know that ln means logarithm in base e. So if I increase my number in front of ln so that the number is bigger than e, definitely what I get for that ln is greater than 1. So if x is greater than e, then ln of x is greater than 1. Yes? If x is somewhere between 0 and e, what happens? Then ln of x is smaller than 1. Yes? This is something, it's not hard to understand. Yes? Okay, so here, let us understand this. ln of 3 is definitely, you are right. ln of 3 is there. Yes, because 3 is bigger than e. So ln of 3 is the correct, ln of 3, I will take it and put it here. Yes, you are right. Somewhere here, I don't know exactly where. And then what about ln of 2? ln of 2 is smaller than e. So it is clear that ln should be smaller than 1. Yes? But how much is smaller than 1? Can it pass and become a negative number? Yes or no?
No.
No, because why? Because 2 is bigger than 1. Okay, so that's also clear. ln of 2 will go here. But ln of 1/2, ln of half is ln of 1 over 2. It becomes negative of ln of 2. Then it becomes, when this is a positive number, minus ln of 2 is definitely a negative number. So you are right. This also comes here. Okay? So if I want to organize this, let me do a limit for this. instead of saying that it be between 0 and 1, let me organize this in this way. If x is greater than e, definitely ln of x is greater than 1. But instead of going up to 0, let us make it two different parts. So first of all, I cannot go below 0. Ln of negative numbers are not defined. Ln is not defined at all. So I have to remain on the positive side for x. So if x is positive, but is smaller than 1, then what happens? Ln of x is a negative value. And if x is greater than 1, but smaller than e, then ln of x is bigger than 1, bigger than 0, but smaller than 1. So these are the ideas that's good to know. Okay? And don't worry, you don't need to memorize. Yes? So first of all, if x is greater than e, ln is an increasing function. If I draw the graph of ln, let me just do it here. Ln, the graph of the ln function is something like this. When I go to the right, it goes up. So it's an increasing function. So what's the meaning of increasing function? It means that if x is greater than e, ln of x has to be greater than ln of e. But ln of e is 1, so you don't need to memorize. You can just take ln from both sides. Yes? And then x is less than 1, so ln of x is less than ln of 1, but ln of 1 is 0. If x is between 1 and e, I can take ln from all sides. Ln of 1 is 0, ln of x is ln of x, ln of e is 1. Okay? So this is something it's good to know. Otherwise, of course, if you have calculator available, you just punch it there and see that which one happens, yes? Okay, so now, what was the problem? The problem, if you remember, we had these two numbers. Now we realize ln of 3 is a positive number. It's even bigger than 1, yes? Ln of 3 is bigger than 1. So if I multiply by a negative sign, definitely it becomes negative. So when I want to put them here in this, I have to respect the order. I have to put minus ln of 3 here and 0 here. Okay? What happens for the derivative at these 2 points? These are 0 and 0. Okay, can you calculate these numbers for me here so that when I'm erasing, I don't need these anymore? So please calculate this and complete the table. Positive, negative, or whatever you need. Yeah, we don't need this. I want exact values, by the way. Don't do approximations unless it is mentioned explicitly in the problem itself. So what I want you to do is to put the exact values here and see which part is negative, which part is positive, determine the decreasing and increasing parts. So what's the number here? This is easy, yes. What's the number there below here? Yes?
0.
No, I think if I am right, that shouldn't be 0.
I got 0.
I told you, don't. This is the information from F. You put it in F prime, yes? So whenever I warn something, be careful. I'm doing it for some purpose. I myself sometimes confuses when I go back quickly. Of course, if you put it here, you get zeros. This is the F row. You see how many times I have repeated this is F prime row, this is F row. Okay, there's a reason for that. Yes. Yeah. This is, you need to know me. When I'm actually telling something over and over again, there is a reason for that. Okay, so let me just do it myself because I want to finish some of the other problems. So if I put 0 here, here is F row. So everything that you want to write here, you need to use F. Okay, so you put 0 there, what will happen? So let me calculate. F of 0 is what? Is 3 over 2 e to power 0, which is 1, minus 4 plus 1 plus 0 plus 1. Agree with me? So this is F of 0. And if you calculate, it becomes what? Minus 3 over 2. Yes? So the number that I have to put here is minus 3 over 2. Okay, now that you know that you have to put it there, I give you a little bit of time. But I want you to find the exact value. Okay? Put minus ln of 3 in this function and try to calculate f of that. Yes? So what I am asking you is to calculate this, the exact value. So it becomes 3 over 2 e to the power of minus 2 ln of 3 minus 4 e to the power of minus ln of 3 minus ln of 3 plus 1. Try to make this as simple as possible. Of course, at the end, ln of 3 will remain there, but we can simplify it more or less in a good to a good extent, actually. What is the Khrushchev formula which is useful here? Do you remember? No formulas? Because if you don't remember that formula, this is useless to wait. Okay, so this is why I'm asking you. First, give me the formula so that I can write it on the board. Which formula is useful for these simplifications? Yes?
Auxiliary variable.
Auxiliary variable is for solving equations usually, not for this case. Yes. No, formula. There is a formula. If you don't remember that formula from the LN lesson, then that's hopeless to wait here. I told you there's a famous formula. We discussed about this. I don't want to go back and discuss everything. E to power ln of a is what? A. So this is equal to A. So remember, this is a very important formula. And whenever you have E with some ln exponent, you need to remind yourself of this formula. E and some ln exponent. Okay? Of course, this is not, they are not exactly this, But if they are exactly this, there is nothing to solve. So this is a problem. So you need to do something. What can I do with -2? What can I do with -1? We solved these kind of problems when I was talking about logarithms. Okay. So what is your suggestion? For example, let us start with this simple one. If I ask you calculate the exact value of this, this is not exactly the formula, because in the formula I do not have any negative sign behind ln. Okay?
So
Yes?
you move the negative sign over 3.
Yes, this is one way of doing that. Yes, there are two ways. This one I myself prefer to move this up there, because this minus sign means -1. Yes, so -1 goes up there. So this becomes e to power ln of 3 to power -1. And now compare this with this formula. 3 to power -1 plays the role of a. Yes? So if you consider this a in your head, this is exactly the formula now. So the answer becomes a itself. So it becomes 3 to the power of -1, which is nothing except a third. Yes? Or you can do it in this way. Minus ln of 3, you can imagine this is e to the power of ln of 3 to the power of -1. Yes? Because if I have an exponent, I raise it to another exponent, the exponents will be multiplied, so I will get this back. But this one in the pair of brackets is exactly the formula. So this is 3, and I have a -1 up there. So these are two different ways to see the problem. Both of them give the same answer, 1/3. And I hope now you understand what you can do with the second one, yes? Just everyone, tell me, what should I do with this one first? What should I do? Yes, I put -2 on top, yes? So this becomes e to power, let us do it in one way here. It becomes ln of 3 to the power of -2. And if I compare this one with this original formula, you see that 3 to the -2 is playing the role of a. Yes? So what happens? The answer is 3 to the power of -2, which is 1/3 to the 2, which is 1/9. Okay, so this part is 1/9. This part is 1/3, but unfortunately I cannot do anything with that. I have to keep it in the exact form. Okay, so let us do that. Therefore, f of -ln of 3 is equal to 3/2 multiplied by this expression, which is 1/9, and then I have -4 multiplied by this expression, which was 1/3. And then I have -ln of 3. I cannot do anything with that. I have to keep it exact. And then I have 1. But of course, there are a bunch of numbers that I still can simplify. So this 3 and this 9 are simplified. It's 1/3, 1/6. So this becomes 1/6 minus 4/3. And let me write 1 close to it. And then -ln of 3 at the end. Let us see how this will work. I have to take the common denominator here, which is 6. 6 to 6 1 times, it is 1. Let me write -8 and then +6. Yeah, please correct me if you see any mistakes. And then 7, I have 7 -8 -1. Yes? So it is just -1/6 minus ln of 3. So this is the number. This is the most simplified version of this expression. I cannot simplify this more than that. So I have to put this number here. -1/6 minus ln of 3. -1/6 minus ln of 3. Please let me know if you don't understand anything. Is there something hard? Yeah, just normal calculations. And then we have to go back and finally to see which part this function, the derivative is positive, and on which part the derivative is negative. Let us start with the simplest possible one. I go after 1, after 0. What is the best random choice here? 1. Again, don't get confused. Don't put it here now. You have to put it in the derivative, yes? So the derivative is in front of your eyes, and I chose 1 to put it here. Just go to scratch paper and calculate. So 3, I am putting 1 instead of x. It becomes e to power 2 minus 4e plus 1. Okay, so might be it is not that clear, but either you can use your calculator or whatever. So I would say that this is 2.7. If I multiply it by 4, it would be around 10.8 something. And then if I raise this one to power 2, what will happen? Yeah, it is bigger then. I don't care, yes? So this is bigger, so that is positive. That's good. Okay, what do you think now I should choose between these two if you don't have any calculator available? What is a random choice there? Of course, that is, by the way, I want you to understand these calculational problems are not hard things. Yes, you just put this in the calculator and then see that what can I choose as a random number there. Yes, but what is ln of 3? 3 is bigger than e. Yes, so ln of 3 is bigger than 1. If I multiply it, it becomes lower than -1. Yes, so this number is lower than -1. Is that acceptable for everyone? ln of 3, because 3 is greater than e, is bigger than 1. So if I multiply this, it is lower than -1. So what is the best random choice there? -1. Yes, and I put -1 here into the derivative. So it becomes e to the power of -2 minus 4 e to the power of -1 plus 1. Then what happens here, do you think? This we need to calculate. I don't know, using calculators somehow. But how can I avoid calculators? So let me write. Let us see. I can write them in this form. Let me take the common denominator. Yes. Then what happens? It becomes 3 minus 4e plus e squared. I don't need to be worried about the denominator because the denominator is positive, e squared. Yes. But now, do you think which one is it positive or negative? Yes.
Positive.
Yeah, it is positive again, but that is a little bit of strange behavior now. Let me check. I put -1 here. I put -1 in my derivative. Yeah, everything is right. And then I wrote this like this, and then I take the common denominator 3 minus 4e plus e squared. I didn't expect that this should be positive. May you check this with your calculator? Do you have calculator with you? Because if this is a positive, that's a very interesting problem. I didn't expect for that. Then if that's a positive, it means that's a terrace point. Might be that's a terrace point. How should I understand that? So let me take the second derivative. 6e to power 2x minus 4. No. Did you calculate it? Just the numerator. Do you have any calculator with you? Yes?
Okay, negative 0.06.
Negative, yeah. Yeah, it was a very topic because I know what's going on. So it was very odd behavior that this is going to be positive again. So this number is negative, yes? Yeah. What is the number here, by the way? How much negative?
Negative 0.06.
Oh, okay. So it was very dangerous, yes? So it was negative. So yeah. Okay. And then, by the way, we should be able to roughly understand that this is negative. That's also a good exercise. Try to see that, can you convince yourself that the numerator should be a negative number here? Because they are very close, yes? So you see that the number is very negative. Okay, now what can I do here now? What is the best random choice before minus ln of 3? So let me ask you, do you think ln of 3 is greater than, is ln of 3 greater than 2 or not? Do you think ln of 3 should be greater than 2 or not? Do you understand how should you see the problem? Because 3, let me write. Do you agree that 3 is between these two values? 3 is between E and E squared. Yes, now take ln. ln of E is 1. ln of 3 is just ln of 3. But what is ln of E squared? Can you tell me? You should be very quick in this. Yes, ln of E squared, 2 goes back, it becomes 2 ln of E. ln of E is famous, it's 1, so it becomes 2. So we realize that ln of 3 is somewhere between 1 and 2. Okay, when ln of 3 is somewhere between 1 and 2, this is somewhere between -2 and -1. Yes, so minus ln of 3 is somewhere between -2 and -1. So what is a good choice? -2. Yes, but of course, I'm telling you, I like to do these things. It's up to you. You can just put your calculator in front of you and do the whole calculations. But doing these without calculators are teaching you a lot of things, just very technical things that it's very important to remember. Okay, so let us choose a -2 here. Then we will have a problem again. So let us put -2 here. Yes? If I put -2 in the derivative, what happens? F prime of -2. What is the answer? It becomes 3e to the power of -4, and then I have -e to the power of -4. -2. And then I have +1. Now the problem is that this is positive or negative. This is definitely positive. Okay, you can check because this becomes 3e to the power of 4. E to the power of 4 because you know that powers are very good when you want to raise something higher and higher. Yes, and if I do this, e to the 4, common denominator is 3 minus 4e squared plus e to the power of 4. I'm completely sure that e to the power of 4 plus 3 is much bigger than that number. By the way, how do you understand that? This is might be we were able to do this there. Let me convince you that this is positive. What do you do? How do you do that? For example, I put 3 here. I factor e squared between these two. When I factor e squared, then it becomes e squared minus 4. Yes, divided by e4. E to the power of 2. E is something 2.7 something. E to the power of 2 is definitely bigger than 4. Because 2 to the power of 2 becomes 4. A little bit bigger than 2, it becomes bigger than 4. Positive, 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 so it is positive. So you don't need calculator. So this becomes positive. Let us finalize this problem. It goes up because it's positive. It goes down and it goes up. So this function has a maximum, one maximum and one minimum. And the maximum is out of reach by guessing, yes? The maximum occurs at minus ln of 3 and minus 1 over 6 minus ln of 3. So I would say that this is the end of this problem. So maximum, so minimum points, let me write minimum first. Minimum point is equal to 0 and minus 3 over 2. It would be nice if we could draw it by GeoGebra to see how this looks like, yes? So maximum, by the way, let us draw it if you want to. So maximum of point, do you have GeoGebra here? So we can check later the qualitative picture that we drew, yes? So this is the maximum point and that's the minimum point. It doesn't have any terrace point. So I think this is a very good exercise if you can predict how the graph looks like and then punch it into, I don't know, GeoGebra or whatever and try to see if your prediction is correct. Okay, so let me leave this for the time being because I want to solve at least one more problem. So I would call this a little bit challenging. Yes, it's not, I don't know, from my point of view, if you haven't forgotten your lessons, it's not that challenging. It's tedious, you need to be careful, but we are just following exactly the same steps. There is a very nice problem in the book. I wrote on a school stuff, I don't know how many of you saw that. I said that these 3 problems in the book, they are very good to emphasize. I don't know those problems, but I just can draw something for myself here. And then I want to ask you, what is your opinion? This is a very nice problem. Okay, so I think this is enough. So you really understand everything about local maximum, local minimum, yes? Now let us go to this. I don't know. I drew some graph like this for you. Okay, so for example, assume that this, I don't know, yeah, it touches the graph. My intention is to say that this is tangent to the x-axis. And then, for example, it goes up. Let us do all of these exercises in one exercise. Okay, for example, this function comes here and then goes back again, touch the graph here, for example, and then goes like this. Okay, but this is not the graph of the function. This is the graph of the derivative of the function. Okay, so this is very important. Of course, in my exams, I emphasize, be careful, this is the derivative. So this is not the graph of the original function. We don't know about that. Okay, someone took the derivative of some function and drew the derivative function. Do you understand what's going on? So I have a function, for example, my function is x to the power of 3. If I ask you, the reason that I actually immigrated to this room is because I wanted to have that board. Okay, so here, for example, if I ask you f of x is equal to x cubed, what I am doing, the graph of this one, you need to trust me on that. It is something like this. Okay? But this is not given to you. Assume that someone imagined this graph in his head, and then you take the derivative, it becomes 3x squared. If you draw the graph of this function, it is something like a parabola, you know, or not something like, it is exactly a parabola, but not exactly x squared. So this graph is given to you. You are supposed to tell me some information regarding the original, the graph of the original function, which is out of reach. Out of reach, yes? So it is, this is my point. Okay, so let me emphasize, let me give names to these points. This is A, this is B, okay, this is C. These points of intersection, I want to give them names. Okay, what are these numbers for f prime function? The question is this. Let me ask you the question. The question is that, can you locate the extreme points and the terrace point, if any, of the original graph? Okay, so what does it mean? It means that if I give you this and I draw the graph of the original function in the same coordinate system, exactly above that, below that, or whatever, I want to see that, can you, using the information on the graph of the derivative, can you say something about the graph of the function itself? Specifically, I want you to locate the extreme points and the terrace points of the original function, if any. Let me ask you one question. What is f prime of A? Can you tell me? Just look at the graph. What is f prime of A? It's a number. What's f prime of A? What's f prime of B? What's f prime of C? What are these numbers? What?
0.
Yeah, why?
Because they're all touching.
Yes, exactly, because this is the graph of my function. These are what you say, null stelle. Yes, these are null stelle of this function. So it means that f prime of A is 0, f prime of B is 0, f prime of C is 0, and f prime of D is also equal to 0. Everybody agrees with this? Because this is not the graph of the function, this is the graph of the derivative function. Okay, now, whenever the derivative is equal to 0, we have a candidate for local maximum, minimum, or a terrace point. So this means that if the graph, we can see the graph, this point on the graph, when I have the graph here, when I go up, I might touch a local minimum, I might touch a local maximum, or I might touch a terrace point. Is that understandable? For the function that I don't have it yet. Why? Because I know that the derivative at these points are 0. So these are candidates for local extreme points or terrace points. But I want you now tell me, which one do you think would be up there? Is it a local maximum or a local minimum or a terrace point? And how you come to that conclusion? This is a very nice question in the book. Yes?
Is it a terrace because the derivatives before and after are positive?
Exactly. Exactly. You see, because how do you understand which part the derivative is positive? Because this is the graph of the derivative. If the graph is above the x-axis, the function is positive. The function is derivative function here. So everywhere that the graph is above the x-axis, the derivative is positive. Wherever the function is below, the graph is below the x-axis, the derivative is negative. Is that understandable? Is that understandable for everyone? Above the x-axis, it means that my function is positive. Below the x-axis, my function is negative. But what is my function? My function is the derivative function here. So above the x-axis, the derivative is positive. Below the x-axis, the derivative is negative. On the other hand, I know that these are candidates for local extreme points or a terrace point. But look, do you remember the content of the first derivative test? How do I understand that a point is a local maximum? I need to see the sign of the derivative before that point and after that point. Yes? If it was negative and then becomes positive, it is a minimum. If it is positive first, then negative, it's a minimum. If it is positive, or negative, it is terrace point. So that is the simple. It's a nice problem, but it is actually very simple. So why? As Dennis has said, actually, this is a terrace point. Why? Because before this point, if I ask you, before this point, the graph of the derivative is this one. It is above the x-axis. So here, the derivative is positive. Don't get confused. Are you getting confused? Because usually I draw this and I say f prime is negative. Do you remember? I said that the graph is decreasing. This is not the graph of f. This is the graph of f prime. Yes? So that is important. So here, f prime is positive, not because this is decreasing, because this is the graph of f prime, and this is above the x-axis. So f prime is positive. What happens after that? Can you tell me what is f prime after that? Just say something, come on. It's positive again. It's above x-axis. And this means that this is happening. What is this one? This is a terrace point. Yes? So this is terrace point. Corresponding to a terrace point. I'm just not writing. I'm a little bit careless here. But this means that this point corresponds to a terrace point. Okay, let us go here. I want to test your understanding again. What do you think would happen for this point? Someone else, please. What happens for this point? You know that the derivative is 0. So it either corresponds to a local minimum or a maximum or a terrace point. Which one is this? Yes, Ruben?
It's a maximum point.
It's a maximum. Let me check myself. So can you tell me why, for example?
Because before the point, the derivative is positive and after it's negative.
Yes. After that, it is negative. Yes, you are right. So positive, negative. Go up and down. So it's a maximum. Yes, exactly. So this is max. Is that understandable? But don't get confused. From here to here, the function is what? From here, this function is decreasing all the time. But who cares? This is the derivative. This is the function. This is the derivative function. Okay, can you tell me what happens for this point now? Someone else. This point corresponds to? Yes?
Terrace point.
It's a terrace point. Yes? It's a terrace point. Thank you. But what type of terrace point? The one that we had first was positive. What we have here? Negative. Yes? Because before that, the graph is below, it's negative. After that, the graph is below, it's negative. So it is negative terrace point. So if I want to draw something up there, it means that I should expect above this, I should expect this behavior. Positive, positive. I should expect something like this above this. I don't know. If I have access to the real graph and I compare them, exactly above this point, the behavior of the function is like that. And below this, above this point or below this point, I don't know. It depends on the function. This means that this is of this type of behavior. But this one is of this type of behavior. And then finally, what is this one? Yes?
Minimum.
It's a minimum. Why? Because here f prime is negative and then turns into a positive value. So that becomes a what? A minimum, as you said. Yes? Is that understandable? So that I would say that this is a very good exercise. Let me make another choice. So let me ask you on one more thing. Did we talk about second derivative or not? So what is second derivative? Do you know? Okay, it will come later. But second derivative is I take the derivative, I get a function, I take another derivative of the new function, it becomes the second derivative. Yes? For example, if I have x to the power of 3, I take one derivative, it becomes 3x squared. I take another derivative, it becomes 6x. This is called second derivative. Okay? Now let me ask you one question. I want to test your understanding. What is the second derivative here? Positive or negative? Do you know? Yes?
Negative.
It's a why?
Because the slope is.
Yeah, the slope is going down. Because if I ask you what is the slope here, it means that I am talking about the derivative of this curve. But this curve is already one derivative, so the derivative of the curve is the second derivative. So this means that the second derivative here is negative. Yes? And then you can play around with these concepts. So this is actually a very good exercise in the book. So I wanted to emphasize on that. Okay. Let me ask you one more question. There are different questions, but let me ask you this. Show that example. This is a good example. I want to see how do you solve this. Example. Show that the midpoint of the line segment that connects the local maximum point of the function where f of x equals to, let me see what I have written there, x to the power of 3 minus 3x squared lie, so that connects the local maximum point of the function to its local minimum point lies on the graph of the function. Yes? So yeah, you need to read and try to digest the problem itself. So show that the midpoint of the line segment that connects the local maximum point of this function to its local minimum lies on the graph of the function itself. So for example, let me just tell you something. How can I draw something which is not? So for example, assume that I have this function. Yeah, let me exaggerate a little bit. So for example, this is a function, okay? There is a local maximum point and there is a local minimum point. I connect these 2 points together, it becomes a line segment, and I find the middle point. This middle point is not on the graph. Understandable? But I want to show that for this function, this happens. If you find the maximum point and minimum point and connect them with a line and find the midpoint again lies on the graph. Is the question clear now? So for example, this asymmetric graph that I have drawn here doesn't have this property apparently. This is the local maximum, this is the local minimum. I connect them, I found the midpoint, but the midpoint is not on the graph itself. We want to show that for this function, this happens, that the midpoint is on the graph. A very simple question. But these kind of questions are considered probably A-level questions because you need to read the text and digest and understand what you need to do. It's very simple. It needs something from Math 2C. If I give you the coordinates of these 2 points, how do you find the coordinate of the midpoint? Do you remember? So do you know what I'm saying? Talking about?
You take the, if you want.
So for example, if I have this point with coordinates A and B, and I have another point with coordinates C and D, I connect them with a line, with a straight line. The middle point, what are the coordinates of this middle point? This is something we studied in Math 2C.
For the x coordinates, you take a plus c divided by 2.
Yeah, the average, exactly. So you add a to c and divide by 2, it becomes the x coordinate. You add the y coordinates and divide by 2, it becomes the y coordinate. So if you have forgotten, please remember these things. They are very important tools in your hand. By the way, have you studied physics or not? You have probably studied a little bit of diagrams about a particle moving x, t, v, t, a, t, or something like that, yes? For example, position with respect to time, velocity with respect to time, I don't know, acceleration with respect to time. Have you discussed about these things, diagrams? So this lesson will help you a lot, actually. Everything you studied there is actually, you can throw it away. Everything here is mathematics, because you didn't have any clue. I will talk a little bit about this. If you understand these things, you don't need to know physics there. You can immediately translate that problem to mathematics. Actually, that's a mathematics problem. It's not a physics problem. So that exactly because you know that this is the derivative of this is the derivative of this. So you want to understand something about this function using this function. Exactly like the behavior that we have here. We had the derivative function. We learned something about the function here. Here, if I give you the graph of the velocity, you should be able to say something about the graph of S. Yes? Here you don't need to check because which one is which is not important in this problem. Of course, if you check, that is, I mean, because if it is guaranteed by the problem itself, you got 2 numbers, yes? And this problem tells you that let us connect the minimum to maximum. So it means that there should be something like that. But this means that you are confirming that this problem is correct. You understand what I mean? Did you finish? Tired, yeah? No problem. How much time we are left? Not that much. So let me talk about this. Please tell me what to do. What's your opinion about this problem? By the way, I would consider it a level problem at the level of the book. It is not harder. Unless you read the text and you don't understand that. You cannot have this analysis for yourself. If you can have it, it's very simpler than all these problems that we talked about today. So tell me, what is the starting point? What is the starting point? Yes?
Take the derivative.
Take the derivative and
Equal it to 0.
equal to 0. Okay, so I will take the derivative. Why I am motivated to do that? Because it is talking about the local extreme points, so I need to find them. Yes? So I need to find them, because otherwise, how should I know what is that line that connecting these two? Okay, so f prime of x is equal to, what is the answer? 3x squared minus 6x. I put it equal to 0, so f prime of x is equal to 0. Then this means that 3x squared minus 6x is equal to 0. I can factor a 3x out. So 3x, and then it becomes x minus 2. Yes? It is equal to 0. Then it means that there are two candidates, but if you want, you can double check that these are real candidates. But if you trust the designer of the question, that is not your responsibility, yes? There are two candidates. In principle, might be both of them are local maximum, might be both of them are local minimum, might be all of them are fake ones, they are terrace points. But if the problem is going to be a right problem, correct problem, it means that one of them should be what? One of them should be a local minimum, one of them should be a local maximum. Okay? If you want, you can double check that. Yes? 5 minutes.
Sure,
Yeah.
absolutely. Tell me.
Yeah. Okay, he came here to defend himself about physics probably. Okay. So x is equal to 0 and x equal to t. X equal to 2. So if you want, you can draw the table, but what you get is that one of them is maximum, one of them is minimum. But in this problem, I hope that you agree, we don't care which one is maximum, which one is minimum. Do you agree? Because I want to find the midpoint between them. Who cares that this point is a minimum and that point is a maximum? So if you want, of course, you can set up a table, but you are actually spending a lot of time for nothing. Okay? So if this problem is going to be correct, then it means that one of them is a local maximum and one of them has to be a local minimum. Otherwise, this problem doesn't make sense in the first place. But what I need points. This is just the x coordinates. Okay, can you tell me what are the local extreme points? One of them is 2. So how should I calculate these y coordinates? Do you know? What should I do? So can you tell me what should I write here? Why? Because I put 0 where? Where? In the derivative or in the function? In the function. So I put the 0 in the function, I get 0. I put 2 where? Again in the function. What's the answer? It is 8 minus 12, it's minus 4. Okay, so I don't know. If you ask me at that point, which one is maximum, which one is minimum, I don't know. If I want, I can set up a table and confirm which one is maximum, which one is minimum, but one of them is maximum, one of them is minimum. Can you tell me what is the midpoint then? What is the midpoint? I need to add these two and divide by 2, which is 1. I need to add these two and divide by 2, which is minus 2. So that is the midpoint of that line that are supposed to connect these 2 points. How can I confirm that this is on the graph again? I'm supposed to confirm that this is on the graph, yes? Put it back in the function. If it holds, it means that yes, it is on the graph. You see, the problem was very simple. But I don't know how many of you were able to solve it. So you need to take a lesson. If you had some problems with understanding this, you need to be able to, let us check and finalize the problem. Instead of y, I put minus 2. And I ask myself, is this equal to if I put 1 here? Is it correct? Yes, because 1 to the 3 is 1, minus 3 times 1 is minus 2. So it becomes minus 2 is equal to minus 2, it's confirmed. So it means that this property is a very nice property for this, and this comes from the fact that this function is symmetric. So the reason is that this is not like this. This is like it's symmetric, exactly symmetric with respect to this. We will later see that this is called an inflection point, and this is a very nice property of third-degree polynomials. The inflection point is always in the midpoint between maximum and minimum, and that's a nice property of the third-degree equations. Okay, let us see. Yeah, let us stop here. Let me just write one question, and I want you to think about it at home. It's a very simple one, but this is also a typical question. So determine A and B such that minus 1 and minus 1 be a local extreme point of the function f of x is equal to ax to the 4th plus bx to the 3. Yes? So determine a and b. I have given you a function of this form. A and b are missing, but I am telling you that 1 and minus 1 is one of the local extreme points of this function. I want you to be able to find A and B. Okay? So I haven't taught any new lesson. I have just solved some exercises. So this is one homework for you. And then, of course, you know what to do with the book as well. And next time, I will teach the new lesson. Okay? Thank you very much. Bye-bye.